Good afternoon, everyone. I'm Zimo. Today I'm going to give you a presentation about my research, the railway ballast improvement using recycled tire. This presentation is divided into three parts: the introduction, analysis of literature review, and the research design. Let's move to the first part, introduction. In this part, I'll show you the general information about my research and make you clear what I'm going to talk about. First, what is my research? Our research direction is to use waste tie as civil engineering material to improve the performance of ballast railway foundation. And why I do this research? Because in Australia, almost all railway systems used ballasted track design. Compared with the concrete foundation track, the construction cost of ballast foundation track is lower, but its short service life is an obvious drawback because its weight bearing capacity. At the same time, in the environmental issues caused by the waste tie, such as fire, mosquito breeding, are becoming a global problem. Third, how did I do this research? This is a secondary research in this field. According to the course guidance, I have read 20 research reports on improving land performance by using waste ties. Then I choose the topic I am interested in, which is the track construction, and focus on the relevant articles. Finally, I analyze and summarize these results and find out the gaps. Okay, please look at the 4 pictures above. What did you see? As we can see, at present, the general treatment method for waste tie is stacking and burying. On one hand, these measures will take up a lot of land resources that are not abundant. On the other hand, the shape of the waste tie can trap rainwater, which can lead to mosquito breeding. Moreover, there is also a high risk of fire in the open dump. Because a large number of harmful chemicals will be released into the air, soil, and groundwater, the fire caused by waste ties is obviously a disaster to the surrounding natural environment. Let's move to my literature review. Second part. According to the literatures I read, tie-derived materials could be used with granular, concrete, ballast, and asphalt. For granular and concrete, researchers found that adding tie particles can significantly improve the geotechnical properties of the mixtures. And for ballast, whether adding complete tie cells in the capping layer or adding the rubber particles in the ballast, the performance of track foundation would be optimized. For the asphalt, tie rubber is usually used to manufacture the modified asphalt to prolong service life, reduce the traffic noise, and environmental impact. Summing up my 20 literatures, I found that no matter how to use tie-derived materials in the field of civil engineering, in the final analysis, they are using the energy absorption characteristics of rubber. By adding tie-derived materials to absorb the energy released to the stressed structure by the external environment, the deformation of the stressed structure is reduced and the load and service life are increased. The picture shown on the left is a ballast truck bed. Ballast actually is a gravel used to support the tracks and the sleepers. And the concrete track bed is on the right. In this system, the supporting structure of railway is all made by concrete. Australia's passenger railways usually use a ballast track system. The advantage of ballast bed is that the foundation can share the load of the rail better, and the construction cost is low. But the disadvantage are that the track bed is easy to deform, and the track maintenance circle is short, and the cost of maintenance is high. Okay, the schematic of diagram of the ballast railway structure layer is shown here. And this layer called capping layer is where we place the tie sail. Perhaps it is because the construction cost of high-speed railway is too high. Since 1980, the Australian government has carried out many feasible studies on high-speed railway, but in the end, it didn't support the construction. So in my understanding, more and more researchers are devoted to improve the performance of ballast railway, which can also reduce the construction cost of Australia high-speed railway, so as to make the high-speed railway run in Australia as soon as possible. In the research literature that I pay more attention to, the author propose that the recycled tie aggregates and gravels should be mixed as capping layer, so as to strengthen the performance of ballast, slow down the degradation process caused by the repeated rolling of trains, and reduce the cost of track maintenance. One of the research reports showed that under the same load condition, the maximum displacement of the ballast in the control group with a conventional capping layer is 10 times of that in the experimental group with a tie sail capping layer. This finding is a strong evidence that recycled ties can be used to improve the performance of track ballast. The last part is my research design. This is a secondary research, as I said before. It draws a conclusion by analyzing and summarizing the findings of various literatures and other authors, and insists on a point of view. This view is dynamic because research in a certain field is always updates. It is much easier than the primary research because there is no need for experiments. By synthesizing the findings of different authors, it discusses a viewpoint from multiple perspectives to improve its reliability and credibility. However, a significant disadvantage of this study is that it is difficult to put forward creative hypotheses without the first-hand experimental data and witness the interesting phenomena in the process of experiment. Okay, that is the end of my presentation, and at last, this is my reference list here. Thank you for watching.